Hello and welcome to the complete CSC guide with my channel, and I'm Sanskriti, and today I'm going to teach you about network topology. Okay, so it's a very important topic in computer networks, and I hope you study well about these all things. Okay, now let's start. So first of all, let's see what is network topology. So network topology basically it's the geographical representation of the links, right? We all know that when we are talking about a network, so obviously the whole construction of the network it's based on some links, right? So this geographical representation of the links, that is our network topology, how we are going to link the whole, or how we are going to construct the whole network. So these construction, the geographical representation of these particular links, how the links have been constructed, or how we are setting the links, that is your topology, that is your network topology, how you are going to construct your link, the whole geographical representation. So topology is the physical layout of computers, which computer you are going to place in which place, and the cables and other connected devices on a network. So main thing is the link, that how you are going to link the whole devices, your computers, your cables, your connecting devices, each and everything, right? So two kinds of topologies are there. First of all, it's your about your physical topology and about your logical topology. So basically two things. Now the main thing is how the layout of your whole construction whole of your whole network is done, that is your topology, that is your geographical representation of the links. Okay, now let's see types of topology. First one is the physical topology, that is the actual layout of your of the computer cables and other network devices, how you are going to connect the whole thing. So that is the main physical topology, that is the physically how you are going to represent, or how you are going to place the computers and your other devices. Okay, now next is your logical topology. What is that? The way in which the network appears to the devices that use it, right? So how it is going to appear to the devices which are using this particular topology, so how it is going to represent that the particular devices, right? So how the network is going to appear, that is your logical topology. Now refers to how the data is actually transferred in a network. Now in each and every topology you will see, what you will see, that how the whole data is going to transfer from one device to another device. Okay, so from one computer to another computer, via which link, via which particular cable. So these particular transfer of the data from one computer to another computer, or one system to another system, to this particular thing is within your logical topology. What is the logic? Physical topology, what is how the physically the orientation is done, that's your physical topology. And the logical topology is how you are going towards the logic behind the particular orientation, that's your logical topology. Okay, so these are the basically two types, how we are going to break the topology in two distinct groups. Okay, now next is selection criteria, right? So selection criteria, how the selection is done. Size, number of nodes of the system. First of all, the main thing is number of nodes of the system, how many nodes, that's what is the size of your system. If it's a big system, then the topology will be different. If it's a small system, then the topology will be different, because it depends upon the how you are going to connect the devices. So obviously how many devices are there, how many nodes you are going to use. So obviously the size of the system is very much a criteria to select your topology, which topology you are going to select, right? Next is cost of the components and service required, which kind of service is required. Okay, so and what is the cost of the components, which components they are, whether they are cheap or whether they are costly, depending upon that also the topology is selected. Now management of network, how you are going to manage the network, that's also important topic, which is very much required. Is also special criteria, or important criteria to select the topology. Architecture of the network. Okay, next is the cable type, what kind of cable you are going to use, that cable type is also an criteria for selecting the topology. Expandability of your network, up to what limit you are going to expand your network. The desired performance, what kind of performance you are expecting from your network, that's also important topic or important criteria. And the reliability, obviously the reliability is a very much important criteria for selecting your network topology. So these are the basically these are the selection criteria based on which we are going to select our network topology, or which topology we will be uh, relaying on. Okay, so next topic is the type of network topology. Now what are the different kinds of network topology? So first is a bus, next ring, star, mesh, tree and hybrid. So these are the types which we use in our network topology. These are the topologies which we use while constructing our network. Okay, so these are the basic types of design. Now first one is our bus topology. Okay, so here you can see that a particular backbone or terminator is there, right? This is the terminator or backbone. You can see here this one, right? Let's see. So this one is the terminator or background, this thing. Okay, so you can see here different, these are the nodes and these are the different computer systems which are connected to that particular backbone. So you can see that this backbone is being connected, these are computers are being connected with this particular backbone. So this is the orientation of a bus topology, where you can see that each and every computer is connected to a particular terminator, which is the backbone, which is connected each and every computer or each and every system, right? And with some nodes they are connected there. Now next, so this is the bus topology. Then how it's going to work, what's the work and how the whole thing is going on in this bus topology, let's see. So here is the working of your bus topology. So here is the working. See, here you can see how the bus topology goes on. So here you can see what's happening. The backbone, so the connecting devices, they are sending their signals, and this is the procedure how the whole thing is going on. Again see, here the animation is going to show you. Now let's see. So this is happening. Okay, so this is how the thing is going on. Now what is a bus topology? So it's also called as a linear topology. Why linear? Since it's connected to a particular line or a particular terminator. Now a bus topology is multi-point. Why multi-point? Since it is connected, the backbone is connected with different points, so it's a multi-point topology, right? Since it is connected with multiple points, here you can see in the diagram also, you will see that it's connected to multi-point. Why it's a multi-point topology? So here you can see why it's a multi-point, so it's connected with multiple points, right? Now here one long cable acts as the backbone to link all the devices. So that particular backbone, that particular long wire which or long cable you see, that is acting as the backbone to link all the devices, right? All the devices, they are linked with that particular backbone. This backbone will help all the devices to be connected by different nodes, and these devices are connected to the backbone by drop lines and taps. So these nodes, these are drop lines or taps which are connecting these devices with the particular backbone. Now drop line is the connection between the devices and the cable, that particular cable and the devices, that particular thing which is connecting these particular devices with the particular cable, that's your backbone, that are known as drop line. And tap, that is the splitter that cut the main link. It is cutting the main link, and this allows only one device to transmit at a time. This is very important, that only one device can transmit at a particular time. So let's see the animation again. Here you can see that a particular device, they can transmit at a particular time. Okay, so here you can see that particular device is transmitting at a particular time. See, okay, so it is transmitting, it is going to all the devices. So this is the thing which is happening in our bus topology, right? So here you can see a figure also, that how the nodes are connected, how the devices are connected within a particular backbone, right? So this is the orientation of a bus topology, how a particular terminator, it is connected with all the devices through some taps and drop lines, right? So this is the thing how the whole orientation is done. Now next you can see here also, see the T connector. Here you can see how the T connector is connecting the device with the particular backbone, and these are the terminators, the last nodes. Okay, so this is what is happening here. Now bus topology, if a device want to communicate with other device on the node, then sends the broadcast message onto the wire. All other devices receive the message. First of all, what the device which wants to send or wants to communicate with the other devices, what it do, it will send a broadcast message via the wire to all the other devices. Then they will receive the message. but only the intended devices accepts and process the message. Obviously everyone, since it's a broadcast message, so what happens in a broadcast message, obviously each and every device will receive that message, but the intended device which I want to send the message, or the device wants to send the message to, that will accept and it will start the process of the message. Okay, the process of the message will be started to sending the message and receiving the message. So the intended device will only just accept it and it will start processing. Not all devices, they are getting the message. Broadcast message means it's been received by each and every device, but the only intended device will start processing, right? So bus topology is a passive topology. That is the passive topology in nature. Okay, so this is what is happening in a bus topology. Now what are the advantages? Ease of installation. Installation is easier than other topologies. Less cabling, since the wire, only the backbone cable is the main cable then which is connected to other devices. So less cabling is done here, less number of cables are used, suitable for temporary and small networks. If your network size is small, as I have already told you, it will be depending on the cables, it will be dependent on the type of network, the size of network. Obviously if you have a small network, then it's perfect for your use and it is suitable for temporary purposes. Okay, but what are the disadvantages now? Difficult reconfiguration and fault isolation. If any kind of fault happens, then to do the fault isolation, to just get the fault point, which point is getting the fault, so isolate that particular point is very it's a troublesome for this type, and it's also too difficult to reconfigure this one. Okay, so difficult to add new devices, since the link, the backbone is connected with the devices already. To link again a new device, a terminator is also there, so obviously to link a new device is very it's difficult to do this kind of thing. Okay, signal reflection at top can degrade in quality. So degradation of quality is also there due to signal reflection at the top point. If any fault in backbone can stop all transmission. Obviously it's a very huge disadvantage in case of this bus topology, right? Since if the backbone have any kind of fault, then obviously the whole system will be in a fault. So it will stop all kind of transmission if any fault is recognized within the your particular backbone. The backbone have any fault, then whole transmission will be stopped at a point. Okay, so only one computer can transmit at a time. It's also a disadvantage, since it's bad for the efficiency of the network, that only one computer can transmit at a time. And limited cable length, cables are less, obviously the cable length is also limited, and number of stations are also limited. So these are the disadvantages of our bus topology, right? And application, most computer motherboards are been using this kind of bus topology. Okay, so this is basically what is about your bus topology. Now next is our ring topology. As you can see here, it's a ring figure, right? It's a rounded figure, and you can see that each and every computer is, or the devices are linked within this ring, particular ring. Okay, so this is the orientation. Now let's see the working of our ring topology. Now first of all, let's see what is the ring topology. In ring topology, each node is connected to the two nearest nodes, so the entire network forms a circle. Like your ring, it's a circle, and each and every node is connected to the two nearest nodes, as it's a ring figure, right? So ring figure, what will be happening? A ring is there and each and every node is connected to the two nearest nodes. Suppose this one is connected with 2 and 3. So it's the nearest two nodes are this, so connected, it's a forming a ring shape. Now what is the thing? The signal is passed in one direction from one device to another device until it reaches the destination. So what is the main thing here? What happens here? Suppose it's a station, is these are the particular device which are connected. Now the signal which have to be passed in, it have to be passed in one direction only. Okay, so it will be passed in one direction only, it is going on. Okay, from one device to another device until the destination is. Suppose this device wants to send to this device and the direction is like this, so obviously it have to travel like this and then it will go to the destination. So it's a disadvantage. Obviously it's a disadvantage, but it have to travel a lot. Now next is what the ring is, the active network. It's an active. The particular bus one was a passive, but it's an active because each computer retransmits what is received, what is receives from previous computer. So whatever the computer is receiving from the previous computer is going on sending that, going on it's just retransmitting it to the next computer. Okay, so to add or delete a device requires changing only two connections. If you want to add a device or if you want to delete a device, you have to deal with two connections, both the nodes, that is the two nodes which are the nearest nodes connected to a particular node. So two connections have to be settled or have to be deleted, or add, you have to change those two connections which where you want to delete or where you want to add a device. Okay, so this is basically what's a ring topology, mainly the ring topology. Okay, so here you can see there are ring topology. Here the primary ring which is connected, and here the secondary ring. So this is what is happening in a particular ring connection when you are taking it as a topology. Here how the thing is going on, the flow of messages like this. Okay, so this, in this direction the message will go. So this computer wants to send to this computer, then it will go like this. So it have to travel to the via all the computers within that particular network. Okay, or within that particular topology. Now you can see here the animation, how the thing is going on. Here from this computer it's just going to all the rings. Okay, all the particular computers. See, this is the thing which is going on. It is going to all the particular computers, then it is coming to the destination. It have to travel to through the all. Now what is the variation of ring topology? Token passing, token ring, you have obviously we will study afterwards. So these are the things which are now within this ring topology. Okay, so token ring topology is there. So that is the variations of your ring topology. Now ring topology advantage, time to send data is known. Whatever is the time to send the data, that is known. Okay, since from which node to which node the data is going to travel, so the time to send the data, when you are going to send the data, that particular time span is known, or the particular instant of time at which I have to send the data, that is known to me. No data collisions are there. Data collisions are not possible, since one at a time only one particular thing is going on. It is going to retransmit, then again it will come to the destination. So no data collisions are there. Easy to install, obviously it's very easy to install. It's only you have to change the two particular nodes which are nearer to the system, or to the device, and easy to reconfigure. Obviously there also again two devices are mainly you have to work with, and fault identification is also easier. So here fault identification is also easier in case of this ring topology. Okay, now disadvantage, what are the disadvantages? First is the unidirectional traffic. Since it is going on in one direction only, so obviously the unidirectional traffic is there. Break in a single ring can break the entire network. This is the very huge disadvantage in ring topology. That is, if some kind of break is there in your ring, then obviously it will break the whole entire network, right? So this is a disadvantage which is with your ring topology. It's expensive also, very much expensive, and requires more cable and network equipments at the starting point. You have to deal with many cables and your equipments, right? Then afterwards you have to deal with two devices if you want to add or delete anything, right? So this is what is about your ring topology. Now next, applications of ring topology. Ring topologies are found in some office buildings or school campuses. There it's used today. High speed LANs made this topology less popular. Now since we are using high speed LANs, now this ring topology had become a less popular topology when we are using high speed LANs. Okay, so this is what is there in your ring topology. Now next one is our star topology. Here what is happening, here all the devices, they are connected to central hub, right? Hub is again a connecting device. So here a hub is there, you can see in the figure, where all the devices are being connected via cables. This is the star topology architecture or the thing. Okay, now let's see. Here this device has a dedicated point to point link to the central controller called hub, act as an exchange. Okay, so this central controller which is controlling the whole topology, the whole systems in the devices in the topology, that is a hub, central controller, right? which is controlling the whole transmission. There is no direct traffic between devices, no direct traffic is there. The whatever thing you want to send to, you have to send to the hub, and then it will retransmit. The transmission occur only through the central hub. The main thing is the central hub, which is the controller, which is getting the message from the devices, and it's retransmitting to whatever the destination is. When device 1 wants to send data to device 2, first sends the data to the hub, which then relays the data to the other connected device. That's I have already told. So this is what is happening. So whenever the computer wants to send some data, it's sending to the hub. The hub is getting that data, and obviously it is sending to the destination, whatever is your destination. Then it is sending that to the particular destination. Okay, now here you can again see the same figure is there. The computer, the hub, printer, everything is connected to the hub. Whatever thing you want to send, it will send to the hub, the hub will send to the destination. This is what is happening here. Okay, so now the animation you can see here what is happening. This is the hub and these are the devices. So when they are sending something to the hub, it's going on. Now let's see the animation. So this is what is happening here. It's sending and it's sending to the different devices. Again, let's see here. Okay, so this animation shows that yeah, it's sending and sending to all the devices at once. It's sending and it will send to all the devices. Now, star topology, what is the advantage? Good option for modern networks. For modern networks is a very good option. Low setup cost. Setup cost is low here in comparison to other two which we have seen. Installation, management and configuration is easy. Since you have to work with the hub only, with the central controller, so obviously the installation, management, configuration, each and everything is easier. Less cabling is needed here also. Cabling obviously that is needed, which is you are going to use for linking to the hub, but less cabling is needed in this thing. Now robustness, that is if one link fails, only the link is affected, all the other links remain active. Since here the link, whatever link is linked with your hub, that is the central controller. So here if any kind of device that is it's affected or it's have some failure, then obviously if had some fault, then that particular device which is linked with your hub, that is affected, that particular thing. So you can remove that one. The other things or the devices, they are perfectly okay, they can work. But the thing with the device of whichever it that's connected, if that have some fault, then it have to be removed. All the things are not removed or they are not affected. Okay, so robustness of the network is very much fulfilled. Now easy to fault identification and to remove the parts. Obviously it's easy to remove the parts, and obviously you can easily find the fault. So fault identification and remove parts, you can easily remove the parts also. Scalable, that is no disruptions to the network when connecting or removing device. Obviously if you want to remove any kind of device, it's very much easier, as since it is scalable. Since you are removing the device or you are going to connect any device, is very much easier in this case. Okay, so it is, since everything is related to that particular hub, right? Now disadvantage, requires more cabling than bus. Obviously in bus the backbone is there and the cabling was very much less than here. Again, in comparison to bus, the cabling is more. Dependency, hub is a single point of failure here. If any device fails, have some fault, just remove the device, sufficient. Others are working correctly. But if the central hub have any kind of fault, then your whole system, when it goes down, the whole system is totally completely dead. That hub is a single point of your failure. If the hub have any kind of default or it is going down, then your whole complete dead system is in front of you. Okay, so this is a huge disadvantage in case of this star topology. It's the hub is the main principal clause of your star topology. Now it's used in local LANs, that's the local area networks, and high speed LAN often sometimes use this kind of star topology. Okay, so this is about your star topology. Now next is your mesh topology, which is the basic topology, mainly basic topology. You can see a mesh created already here. So you can see that these computers, each and every computer is linked to each and every computer, which obviously it's a mesh here. Now what is the thing, that is in mesh topology here, each and every device has a point to point link to each and every other device. So they are linked to each and every device. It's a complete mesh, right? Now node 1 must be connected with n minus 1 nodes. If I have 8 nodes, then obviously my particular node should be connected to 7 nodes, that is the n minus 1 nodes, each and other nodes. my node is connected to the other 7 nodes. That's if 8 nodes are there, then my node is connected to all other 7 nodes, right? Each and every node is connected to each and every node. Okay, now a fully connected mesh can have n into n minus 1 by 2 physical channels to link n devices. It must have n minus 1 input output ports also. Okay, so this is what is in your mesh topology. Mesh topology is totally each and everything have to be connected to each and every other thing. Okay, now advantage, they use dedicated links, so each link can only carry its own data load. They are having dedicated point to point links, so that each particular node will carry its only load, data load, right? It's not going to carry others data load. One node is connected to other one, so obviously that will only just carry the data load of that particular node. From this computer to this computer, that particular data node is going to carry the whole data load is being carried by this particular node, right? So traffic problem can be avoided. Obviously traffic problem is avoided here, since they are dedicated nodes are there. Okay, so dedicated links are there. It is robust, obviously it's robust. If any one link get damaged, it cannot affect other. If any link is damaged, just remove that one, it's not going to affect the others. They are dedicated links, right? So obviously if one link is having any fault, then that link have to be removed. Every link is not going to get damaged, or it's not going to affect others. It gives privacy and security. Obviously since dedicated links are there, so no hindrance is present, so obviously it is giving a privacy and security. Message travels along a dedicated link. Okay, so security purposes high here. Fault identification and fault isolation are obviously easier here than other topologies. Here you can see how these nodes are connected. So obviously each and every node, this computer to this computer, then this node is only a dedicated link here, again to this to this. So the traffic is minimum, so traffic is not there, not going to hamper any kind of message or data transfer. Applications are what? Telephone, regional office, WAN, wide area network uses this kind of mesh topology. Okay, so each and every node is connected. Now next is your tree topology, alternatively referred to as a star bus topology. Tree topology is also known as star bus topology. It's a combination. Tree topology is one of the most common network setup that is similar to a bus topology and a star topology. Obviously it's a connection or a combination. A tree topology connects multiple star networks to other star networks. So it is going to connect many star networks to multiple other star networks. Okay, now here what is happening? Alternatively, this is a star. Now hierarchical model advantages are scalable, easy implementation and easy troubleshooting is there in your this particular model, that is your tree topology, right? Now here you can see a tree topology, that this is a tree, this is a tree. They are star in nature, but they are linked via a bus topology, a single backbone. Again, it's a bus topology. So this star and this star, they are connected to a particular by a particular bus topology, right? So this is your tree topology. Next one is your hybrid topology, a network which contains all type of physical structure and connected under a single backbone channel. Hybrid means you can use different kind of topologies under within a particular topology. Okay, it's a combination or it's a mixture of different kinds of topology which is a hybrid. Here you can see this is the hybrid topology, where this is one type, this is one type. They are connected via bus topology. So here also they are connected via bus topology. There is ring topologies, there is a star topology is there. So many kinds of topologies are being connected. So each and topology you can get here. It's a mixture of topologies. So now what kind of topologies we have? Bus, ring, star, extended star, which is extended star can also be there, which is again a expanded form of your star topology. Hierarchical topology, that is hierarchical topology means your tree topology. Okay, that is also known as hierarchical topology and your mesh topology. So these are the different kinds of topologies which are present when you are going to study about this architecture or your or the whole physical construction or logical construction of your network. So these are the different kinds of topologies within your topology chapter. I hope you have understood the whole thing, the whole matter. If you have any kind of query, any kind of suggestions, you can give to the comment section. And if you want to like the channel, you can like. If you have got any kind of confusion, you can ask that also, regarding this chapter or regarding the previous chapters also, or the previous whatever topic we have studied till now today. And if you like my channel, if you have got any kind of benefit from this particular video or the other videos, please like the channel, subscribe, and share this with your friends. The complete CSE guide. Thank you and take care. Till then, goodbye.